All right, let's get started. Welcome everyone, and thank you for joining our webinar today. My name is Lauri Hytinen. I'm moderator for the webinar today. The webinar's title is Future-Proofing the Automotive Supply Chain, the Power of RFID for RTI Management. We have two presenters today. We have Paul Jakubic, Business Development Manager from Avery Dennison SmartTrack, and Alexander Delpork from Turck Vilant Systems, who's working as a sales director. A couple of housekeeping topics before we start. The webinar will be recorded, and from the bottom, you can find a Q&A button. So if you have any questions to our presenters today, please type in your questions there. A couple things before our expert will start the presentation, just to highlight some key benefits of the RFID technology. RFID is building the bridge between the physical and digital worlds. It can offer unique ID for all automotive items and RTIs, returnable transport items. It's easy to read, it can be automatically read without line of sight, and huge number of items can be read almost simultaneously. Our experts today will tell you more how these benefits are seen in the real-life applications in the automotive industry. Alex, handing over to you.
Yes, thank you very much, Lauri. Hey everybody, I'm Alexander from Turck Vilant. Great to see you here. A little bit about myself. I've been working with RFID solutions at Turck Vilant for the past 8 years. So I have quite good knowledge in RFID in general. And we at Turck Vilant Systems, we deliver turnkey track and trace solutions when it comes to RFID. We have an in-house developed software, which is fully built from the scratch. We work not only with RFID, but we also work with low energy and GPIs and other technologies as well. In most of our cases, we do integration to customer backends. So we integrate our middleware to the customer's ERP system or warehouse management system, for example. And the typical equipment or RFID read stations that we use are conveyor belts, dock doors, forklifts, etc. And here on the right-hand side, you can see some data about us, and that we're active in over 10,000 sites around the world. We have, together with our mother company, we have offices in 41 different countries. And we serve 35% of companies listed under the motor vehicle and parts on the Fortune 500 list. Please, if we could move to next slide. And here you can see where we are located around the world. So offices in many countries. So we have a global reach, and we are ready to help you with your RFID project globally. So thank you. Over to you, Paul.
Thank you, Alex. Good morning, good afternoon, good evening, wherever you may be. My name is Paul Jakubic, and I am a business development manager here at Avery Dennison SmartTrack, with a focus on automotive applications, automotive solutions. I will start today by sharing a little bit about who we are, and then give an overview or summary of some of the trends that we are seeing for RTI management. A little bit about Avery Dennison. We are a global materials science and manufacturing company. We specialize in the design and manufacturing of labeling and functional materials. As mentioned earlier by Lauri, we believe that the digital ID solutions do bridge the gap between physical and the digital. It enables businesses to add digital connectivity to any item, and we'll be talking about that today as it relates to the supply chain. Avery Dennison as a company, we're an $8.4 billion organization operating in over 50 countries, 35,000 global employees, many patents. And as you'll see on the next slide, we have 5 R&D facilities globally. We have 6 iLabs or customer centers globally, as well as 7 RFID inlay manufacturing facilities as well. So no matter where you're at, or if you're multi-continent companies, between Turck Vilant Systems and ourselves, we can support your requirements. So some of our competitive advantages is not only are we in 50 plus locations worldwide, within that we have 200 operating locations. We are an industry leader with our global footprint, but we also have a strong presence in emerging markets as well. We are a material sciences company, which allows us to vertically integrate adhesives into the overall solution. Because as we talk about in a little while, the adhesive is very important because you have different properties for the different types of services that the RFID tag will be adhered to. We have an innovative process technology that results in operational and commercial excellence. And our industry-leading innovations do enable your organizations the functionality and sustainability required to both meet your specific needs as well as compliant requirements that we'll talk about shortly. So, where are these trends? Why are they happening? Well, the global OEMs are driving global applications. As you see here in the center, the global OEMs are the ones that are mandating that product be identified, that product be tagged. But 10, 15, 20 years ago, everybody was doing it their own way, their own proprietary ways. So what then happened is there's a number of consortiums that were able to come into existence that standardized how this information is reported, such as AIG here in the States, ODET over in Europe, with VDA and Gallia being Germany and French organizations respectively. Over in Japan, you have JAMA and JAPIA. Again, we're trying to get things so that the information can be shared and not just a proprietary solution for individual organizations. This is all handled also through the RAIN Alliance, which is basically the standards-based organization for RFID. Why does this all matter? Is because there's some compliance that is coming into effect as early as 2027. Two of the most specific ones are DPP, or Digital Product Passport, or DBP, which is the Digital Battery Passport. Both of these organizations, or both of these mandates, I should say, are compliance regulations that have started over in Europe and are going to be worldwide requirements. DPP, most specifically, as of today, has been identified for textiles, so the apparel industry, as well as battery, EV batteries in particular. And that's what today's automotive requirements are being directed by. DBP is a subset of DPP, or Digital Battery Passport. And what that means is there's the requirement for the identification of all components from cradle to grave. So, as an example, what comes out of the mine has to be identified. What goes into the refineries has to be identified. What comes out of those refineries and goes into the individual cell manufacturing needs to be identified, and so forth. So you go from the cell to the module, to the battery platform, to the vehicle. Okay, and that's just the manufacturing side. But since this is a cradle to grave initiative, once it goes from the manufacturing facility, it goes on to trucks. It goes then to the dealerships, and it goes on to the end user consumer. And ultimately, it has to be disposed. And these mandates, these compliance regulations, need you to identify it from cradle to grave. And one of the easiest and most accurate solutions is through the use of RFID. So where are we today? Today, it's primarily just used between the tier ones and the OEMs. The OEMs mandate it to the tier ones. The tier ones have to comply if they want to sell their solutions to the OEMs. But where this works best is where the tier ones actually are able to use it themselves for their own internal operations, so that they too can see productivity improvements. They too can see inventory accuracy. And once they are able to better utilize it, the cost of implementing it for the OEM actually becomes a cost savings to the tier one suppliers. The OEMs can then utilize it for their manufacturing operations the inventory and the receiving, and the various applications within the OEM plants and distribution centers. But that's where we are today, which is actually very limited. Where we're going to see tomorrow is basically complete upstream and complete downstream utilization of RFID and the information from your very small suppliers, your tier 3s, your tier 4s, okay? That could be the raw materials people, okay? It then goes to the tier 2s, ultimately to the tier 1s, and to the OEMs. And as I just mentioned, because it needs to go downstream, it's going to go through the transportation organizations. It's going to go to the dealerships, and it's ultimately going to go to the customers and the recycle facilities as well. So what's critical and what's missing today is actually the information flow, okay? And that information flow is actually trying to be handled through Catena X. And Catena X, and I'm going to read this almost verbatim because I'm not even that knowledgeable on Catena X, but one of the project goals of Catena X is the development of standards for data and information flows, which are essential for cross-sectorial collaboration. Today, the majority of the companies already store and evaluate their data, but a lack of collaboration prevents them from creating seamless data chains. For example, what we have is a disjointed, incomplete, and non-transparent supply chain. And this is actually where Catena X comes in. So along with the OEMs mandating the consortiums like ODET, AIG, JAMA, JAPIA, providing what information needs to be captured, Catena X, due to DBP and DPP, is the organization that's trying to define how these are all linked together and how you have a standard information flow along with your overall product flow. So what are some of the key issues today, and where can RFID help? I mentioned about Catena X and how there's really a non-transparent supply chain. We need full visibility from the component manufacturing to the car assembly line. The pandemic showed us that even though we thought we may have had that visibility, we really didn't have it. And now we need it because we need to know where the product is, where the parts are at any given time. One of the easiest ways to do that is automated shipping and receiving processes. Okay, and RFID can help in that. You don't have manual intervention. You don't have people having to scan barcodes. You can automate the receiving via RFID because you do not need line of sight. And even though we're all human, right? So the reduction in the possibility of human error through the use of RFID, even though these errors are unintentional, definitely helps in increasing the transparency of that supply chain. And the area where I think is probably most important is the full traceability for recall, for containment processes. Okay, if you think about Firestone tires, GM ignitions, Takata airbags, any of those 3 recalls resulted in, unfortunately, many injuries and deaths. If we were able to identify via the proper lots, via a better way of identifying which of the vehicles needed repair, instead of doing a global recall that had to be done in every single one of those situations, if we were able to focus and dig deep right into those lots of products that needed to be recalled, we would have not had the expense of a global recall of all products. And most importantly, we would not have had the global expense of many lives lost to an unfortunate situation and circumstance. RFID can help eliminate that because we can identify down to the component level and lot level exactly what information is needed and what can be captured easily without line of sight or human intervention. We also have incomplete controls of the manufacturing process. It's something we call manufacturing excellence, or the way to attain manufacturing excellence. It's also called production control. It's also called error proofing. What are we doing? We're ensuring that the right parts and components and tools are at the right location at the right time in order to assure that there's no work stoppages, no production line stoppages due to missing parts or later arriving parts. In some ways, having product in your facility and not being able to locate them and find them is almost as bad as not having product at all, because it's the same result. Line stops, significant issues occurred to that. RFID can help in trying to avoid or eliminating or at least reducing that situation. And RFID also works where optical codes fail. Vision systems may not work, barcode may not work. Good example is in body shops and paint lines, where RFID is an excellent solution. And the last area where RFID can help, or the last pillar, is anti-counterfeiting and theft deterrence. RFID can be encrypted digitally. It cannot be copied. It can be attached or embedded, so it can be a visible or invisible deterrent. And another nice thing is you can externally, outside the four walls of the plant, you may be able to just utilize your smartphone. So a lot of the bulk reading can be done via something as simple as a smartphone, and the infrastructure is not required for that particular application. So what are some applications? I'll start top left. 4x6 standardized shipping labels. Used to be barcode only. Now you see RFID inlays that are converted into these labels. The two center top pictures, different form factors of RFID labels that can go on plastics, can go on metal, can go on wood, can go on glass, whatever the different products are that it needs to be adhered to. With our material sciences capabilities and our adhesive capabilities, we can actually support that. We can tune it and we can optimize it. The top right corner, what we're here talking about today and what Alex will get to in a little while, your returnable containers, your RTIs. These happen to be Gaylords, but it could be a Gaylord, it could be an engineered rack, it could be a plastic tote. Anything that product can be stored and shipped, and especially if it's a returnable container, RFID can benefit. Bottom left are paint shops, body shops, high temp, on metal products that are going through paint booths, through body shops. Wiring harnesses in the center here, along with on metal tags. Different sort of tag, different sort of application, and then batteries. Batteries, this could be just an information label, but if you add RFID to it, now you've got tracking. This happens to be just your standard car battery, but through the requirements of EV batteries now, we've got significantly more application opportunities for all of us out there. So I talked about application areas. I've in detail sort of talked about component parts manufacturing excellence, but there's also logistics and quality control, as well as tire tagging and sensors. One of the things that I want to mention here is that Avery Dennison is really the only company offering specifically designed RFID inlays for automotive use cases, all automotive use cases. We're not trying to put a square peg in a round hole. We're not trying to use a retail inlay for an automotive. We engineer, we optimize, we design to the specific applications. So again, automotive application areas in the red, we've got parts and component management, whether it be the identification of products, both inbound, outbound, as well as to the assembly line. You got Kanban and RTI management. You got the overall lifecycle management. In the grays, we got the production control, paint and body shop identification. And then something I hadn't mentioned yet is the electronic BOM for a vehicle. As something is rolling off, as the vehicle is rolling off the assembly line, you can actually scan the vehicle and capture all of the RFID information. In so doing, you now have a full-fledged electronic BOM for that vehicle. You can capture it along the assembly line, but you can also validate at the end of the assembly line through the use of RFID. And then the future growth areas. Tire tagging is becoming very prevalent. We're very much involved in that. your EV modules, your cells, your modules themselves, as well as your battery platforms. Something that the requirement has been around for quite a while, but really hasn't been fully vetted yet, is leakage detection. Having a leak in a vehicle for a new vehicle coming off the assembly line and it gets to the customer, that customer experience drops significantly. If we can detect it as part of the assembly line operations, it's a huge win. It's a huge benefit. We talked a little bit earlier about spare part identification, aftermarket, as well as the new compliance for DPP and DBP. And then if you wrap all this in a whole bow, you have sustainability, the reuse or second life of products, as well as the recycling of those products. So as I mentioned, we at Avery Dennison have specific products, for that parts management and vehicle tracking. We offer a wide variety of Impinj and NXP ICs for the particular application environments. One of the products I'd like to mention is AD2 metal rock you see in the bottom. That's a new product of ours. It's very unique and interesting because it's a non-metal product, but also can be used specifically for liquids, for carbon fiber, and for ESD totes and plastic totes or on-metal tote. So again, RTI Management. We're also involved with tire traceability. We have an embedded version for the Maxdura tire tag that is actually inserted as part of the vulcanization process of the tires. The AD grip is actually for the Walmart initiatives and for the labeling on the tire treads themselves. It's more of a retail application. And lastly, we have our Pure line of products, which is made with a low carbon footprint process that results in a 95% or 100% plastic free and recyclable product at the end. So again, many different applications, many different usages, and ultimately a sustainable product as well. And lastly, before I turn it over to Alex, RTI application areas for RFID labels in automotive. Everything in the red that's noted here is a utilization of some sort of RTI, whether it be an engineered rack, a Gaylord, a tote, a box, whatever the case may be, okay, from inbound materials logistics all the way through spare parts logistics and every sort of manufacturing operation in between. And I've noted those in the red, but even tooling has RFID usage, vehicle storage and distribution has RFID usage, and the customer experience as well. Think about a car being tagged with RFID. Think about you heading into a dealership and all of a sudden they say, "Hello, Mr. or Mrs. Such and Such. We see that you're here today for your oil change or your brakes or your 100,000 mile inspection." Just knowing that up front is a better customer experience. RFID has a time and a place for each of these areas, and we'd welcome the opportunity to work with you along with Turck Vilant Systems in offering the different ways that RFID can benefit you and your customers. I'm going to turn it over to Alex now for some specific use cases in RFID. Alex, all yours.
Thank you very much, Paul. Yeah, if we could move to the next slide, I will then a little bit, let's see. Yeah, again, that inform that our solutions then are made for kind of complex situations, which is typical within the automotive. And as Paul earlier has also explained, it's you have the possibility of reading several items at the same time. We don't never necessarily need this to see the actual product or the actual tag. We can read it anyway. We can identify it on forklifts and gates and so on. And the labels, I mean, they can get mud or they can be harsh environments. The RFID labels can be read anyway, so it can work in areas where the traditional or physical labels necessarily would not work. if we go to the next slide, and today I will be presenting 3 different customer cases, and the first case will be Nokian Tires, and what we will be focusing on here are the RTIs that is where the raw material is placed on in a production. So we're actually interested in the raw material itself, but it's made possible throughout the RTI. Then secondly, the case I will go over, it's a bumper manufacturer, and here we will track the RTI, but also the products. So we have moved from raw material at Nokian Tires into the product, and the RTIs handling the products after the production site. And then lastly, I will be presenting a case where we look at the RTIs themselves and an RTI pooling case where the RTI is the interesting thing and actually not the products. But let's go more into detail into the different cases, and let's start off with Nokian Tires. And this is an overview of the process at Nokian Tires. So what we can see here is, number 1, the raw materials are received to the factory. It's then put on the RTIs, and the raw material is linked to the RTI itself. It's then taken by a forklift to this position number 2, and it's put to stock. And thanks to the RTI, we can register the location of the raw materials. We know where the exact raw material is located. Then at the production, number 3, when a production line needs some raw material, it's brought there, and before it's taken into use, we read the RTI, and by that we know, okay, it's this raw material, so we register what raw material is being used at that step. And then lastly, number 4, is kind of we get the data of the consumption and can kind of place automatic replenishment to secure the stock again. Then please next. But why did then Nokian Tires invest in this system? And their production process is, I mean, the raw materials, they look very similar. So the challenge they had in the beginning is that, or before implementing RFID, the operators could take wrong material even though they thought it was the correct one because it was so similar to the material they should have been taken. So it's basically human error. But what we then implemented was tagging all the RTIs, and there are different kind of RTIs. It's boxes, metal carriers, and so on. But we tagged all the different RTIs, and then we linked the raw material to the RTI. And then whenever this RTI and the raw material on it was taken to the production, we read the RTI and send the information to the backend system, which tells us this is okay or not to be used. And then if it's the correct raw material, the production can, or the machine can start, otherwise it won't start. So it has really like increased the quality. So kind of the result is that this customer now have full visibility of the materials used. They have real-time production data on what materials that has been used. And even more benefits that they have seen is that thanks over the years, they've been able to see when they get some claims with this detailed traceability on every single raw material that's put into that specific mix, they've been able to make their mixes, because they make different tires, summer tires, winter tires for trucks, for cars. So they've been able to fine tune the mix into the best possible mix. And even furthermore, I mean, they have different suppliers or partners that are providing the same raw material. And with this system, they can actually see what partner or supplier that provides the best raw material, because they're able to track back to the history. If they have gotten a claim, they can see the correlation. Okay, then we have used the raw material from this supplier. Let's not do that in the future. So it has given them great advantage using this RFID system throughout the years. Then moving over to the next one, which is a bumper manufacturer. So just shortly introduce it. So you can see the bumpers here on these steel carriers. So these steel carriers here in this case are the RTIs themselves. So those are RFID labeled, but then also the bumpers, they get one RFID tag each. And then if we could move to the next one, we'll see the overhead process. So in this process, or at this customer, this is number one is where the end of the production. So we have a ready bumper. What then happens is that the bumper gets an RFID label, and the bumper is placed on the skids or these RTIs. So then all the bumpers are married to one skid or the RTI going along this conveyor belt here and to the paint line number 2. Then in the beginning we read the RTI to verify, okay, it has these type of bumpers, so that we can forward to the backend system what kind of bumper this is, so that the correct settings kind of in the paint line or body shop can be used. And like Paul earlier mentioned, the tags survive the heat and the paint. There's no issue on that side. Then we have read station afterwards, and the number 3 here, there's a quality inspection. Bumpers which did not kind of pass the quality inspection are registered to number 4 and being reworked. The ones that pass the quality check moves to this number 5 and are then again read and updated in the system, and it's moved to the stock and the mezzanine floor upstairs. Then when customer purchase this or they move on, they are registered at number 6, another point automatically that they now have been consumed. And then if we can use the next slide. So the challenge in this case is that there was before manual handling, and they needed to automate the whole production line. It was also the lack of the visibility of the production process, which they wanted to increase. And then of course the real-time production data, where in the process are the different bumpers and the RTIs. So with this system, I mean, all the bumpers were tagged, the RTIs were also labeled, and in strategic positions such as the paint line, that's where the RFID readers were placed, and this allowed them to have a fully automated production line, no need for manual scanning or operators. They get all the data in real time. We send it to their backend system. So no more manual checkpoints as well throughout the whole production. And then we lastly can move to the last case, where we'll be focusing on the RTIs themselves when they're leaving the factory. So this is a quote here. So it's the loss of RTIs in the automotive industry in the North America alone is estimated to be $1 billion. So the loss of those costs $1 billion. And this is a number that I myself strongly believe, because when I'm at customers, and especially when it comes to these RTIs, I mean, the first question I basically ask, and this is a question that I could ask you, the audience here as well, and you could think of, how many RTIs or returnable transport units do you have in your system? And the answers I typically get is that we think that we have 50,000 units, or it's like we've been purchasing 5,000 units each year for the past 5 years, so we should have this amount. But very seldom that the customers are able to tell me how many they have. And this is the motivation for this next customer, if you would, to implement the system. And what kind of system did they then implement? Yeah, starting here by 1. Whenever new RTIs kind of is made, or new ones are purchased, they are registered into the pooling, and an RFID label are attached to them. Then number 2 is when the RTIs with the products are leaving the site, we register them and to which customer or which factory it's going to, so that we know that it has now left our factory and this customer or factory should be receiving it. Then number 3 is when the same RTI is returned either through your own factory or to another factory which also have the RFID system installed. Then whenever it's received, and at this station number 4, that maintenance can be done. So as the RTIs have unique IDs and the labels, we know exactly what earlier might have been done to this RTI by checking the maintenance history and so on, or if we need to do any new maintenance to that specific RTI, we can register to it. And then lastly, when it's past the maintenance check, it's registered back into the pool at step number 5. And then if we could take the next picture here. So this specific, these are the RTIs here up here, which Paul earlier mentioned as well. But this customer in their solution, it's in over 15 countries. So this is not only in one factory; it's globally. So they equipped their different facilities around the world with RFID readers and gates and the software from Turck Vilant. So we're able to track now the 70,000 RTIs that they have in their system and to know the whereabouts. And kind of just by informing this, like they lost RTIs before, and now informing the different customers that we know what unique RTI that we shipped to you, just this kind of increased the return rate of these RTIs. But in the end, the result for this customer is that they know how many RTIs they have and where they are. And if a RTI is lost, they know which customer who lost it or which factory that lost it. And then potentially you can discuss, okay, who should actually be paying for this lost RTI. And then the result, like I mentioned, first, faster RTI turnaround times. When you have a system and you have full control and visibility of your RTIs, they seem to be returned quickly because people or companies don't want to pay for lost RTIs. So then we can move to the next one. Yeah. So those were the three cases, and then I'm shortly elaborate a little bit on the ROI of implementing an RFID system in general in the automotive industry. And of course, one big thing is the manual scanning. There is no need for the manual scan. We don't need to have line on site. Bumpers, RTIs can pass seamlessly, basically. No need to stopping. We can read them. So obviously the production will be increased. No need to stop, and automatic registration. And then later in the process as well, for example, when you are shipping products or RTIs to customers, you don't need to manually register them at that location either. We can have RFID gates or RFID forklifts, which registers the shipment. And then next one, please, Paul. And then a little bit on about our typical solution. So of course, here today we've been speaking about the automotive applications, but we have other applications and tracking solutions as well. We are logistics and transportation is of course a big business for us, such as the pulp and paper industry. So we begin those areas as well. And then mainly what we work with are these RFID gates or RFID forklifts, which has become very popular. And then kind of identifying assets that the forklifts are transporting, and even maybe with some Bluetooth system or similar, we can identify where the products in a very detailed level, the location of the products, where they have been placed as well. And then going to my last slide, talking, if we could move. Yeah, and a little bit about the software that we do provide. So I've been talking about, okay, reading on the conveyor lines and everything, but the actual software behind and making this possible is this visibility manager. So it's a software where all the events and the information are sent to, and it's a server application that has great features and reporting possibilities. But in most cases, this visibility manager or the RFID server talks to the customer backend and sometimes also receives information back so that we can do special commands or to the readers or stop some conveyor readers or so on. And secondly, we also have a device manager. So this is a system where all the equipment throughout the production or your factory are registered here so that we can see and monitor the status of the different readers. If for some reason the network would go down to one reader or a forklift would hit a reader and destroy it, we will get an alarm so that we know directly when it happens if a reader for some reason actually would go down. And that's what I had for for now. So over to you again, Paul.
Okay, thank you, Alex. My computer is acting up and is not necessarily cooperating with some of these. Hold on a second here. Oh, there we go. Sorry about that, everyone. So, in closing, before our Q&A, I want to thank Alex for the information that he's provided today. I guess probably a summary of everything that we heard today is that between Turck Vilant Systems and Avery Dennison, we have a wide variety of labeling solutions, turnkey solutions for automotive applications from coast to coast in the US, from all the ends of the globe, because we both are global organizations, and in the vehicle itself from bumper to bumper. So there is a solution out there for you, and we would welcome the opportunity to help you in any way that we can. So I thank you for your time today.